Hello everyone, I'm going today to talk about the custom-made mesh for ridge augmentation, or let's say GBR, guided bone restoration. The post I have published recently, it was about this mesh, and after discussing with our scientists and our surgeons, Dr. Hani Baza, Dr. Mahmoud Shalash, Dr. Muhammad Musab, I have come to some conclusions. This case was done just for a virtual trial, for virtual case, and I have come to some conclusions. I hope it would be useful for you. These photos are screenshots from the software I have used, Slicer, then Blender for Dental. If you see here, this is a custom-made mesh. It is made for guided bone regeneration. There are two errors happened here. We will discuss these errors later. Let's start from the beginning. If you have a patient come to your clinic and the vertical distance between the implant, the shortest implant, and the nerve is like this, and you have this space here. The coronal part of the implant, it is not covered by bone, and there is horizontal and vertical bone defect or bone loss. So you're going to guided bone regeneration. People have a debate about meshes, the titanium one, whatever the other types, zirconia, custom-made zirconia, custom-made PEEK, whatever these types, there is a debate about this. But what I have found with my talks with our scientists, I have mentioned before that when you have a large defect, you can go for the custom-made and like titanium, which is rigid, or custom-made zirconia or PEEK, because you have a large defect and you are afraid of moving of your graft, so you want to make sure that it is stable enough. But if you have a small defect and maybe it is just horizontal defect, you can go for resorbable membranes. So in this case, as I told you before, I have made it just for trying the software and trying the capabilities I can make with the software. I have using the sculpt mode to increase the size of the bone, was taking care that the base of the added volume is stable and kept as it is with the dimensions. But here is the coronal part. I have added some, some volume with the sculpt. Like this is a cross section. Here we can see the original or the start point of the ridge, and the upper part, it is the estimated bone volume needed to cover the coronal part of the implant. I have made the mesh. This is regarding the screws to fix this mesh to the bone. What's the size of the screws you are using? Some people use 1.5, 1.2. So regarding this case, it was 1.5. So I make it smaller, smaller bit or a little bit larger, 1.6. And add 3 of them to have the tripod effect. This is the mesh I made, and this is the holes I made. Let's talk about the errors. The errors here, it was after making in a splint module in the Blender, after drawing the layer and after finishing it, and the Boolean operations, the difference between the layer I have drawn and the substructure of the model, the block out model, this all are the steps, the ordinary steps of the module. The two errors that I told you about in the first of my talk, first one is the thickness. It is preferable to make the thickness 0.5, 0.6. You know that the titanium mesh is 0.2 or 0.3. So if you want to make a custom-made mesh, it is favorable to make it thin, but not brittle. So you can go for the manufacturer information about the material you are going to mill and read carefully the minimal thickness of the material or you can do some research work to try multiple thickness and test it and use it and try it with the screw. It's going to brittle, it's going to be fractured or what. So number one, it is very thick, so you have to make it thinner. Maybe 0.5 is enough, 0.6 if it is zirconia, and you are trying by your error, try and error to make it more thinner. Error number two, as you see here, this is a large hole. Large hole, it is just not as it is artistic. No, there is a science behind this hole. The science tells us that fibroblasts grow faster and have a larger and faster activity than osteoblasts. This is natural, but we didn't need fibers to be formed here. Instead, we need osteoblast to take its time to get us the bone we need. So if we make the hole like this, we are helping the fibroblast to go faster and take the place of the osteoblast, and fibers will be formed instead of bone that we need. So what can we do? We can do smaller holes. Smaller holes, what dimensions? What's the preferred diameter you are suggesting? The preferred diameter is about 30 to 40 micron. Can you see? It's not that large holes as you see here. You have to make it as smaller as you can. Why is that? To help the fibroblast not to invade this mesh and give time to osteoblast to form the bone by natural. So there will be a questions you're thinking about. True, you're thinking about why not we made it solid. That's a good one. That's a good one. If you follow the research about this topic, you will see that some researchers made a comparison between the mesh with holes inside it and the solid mesh without holes inside it. And there are some results from research work. You can Google it and you can learn more about it. But some people have another opinion. They said that if you made a micron, like as I said, 30 micron diameter hole, you can allow the bone to get more nutrition, more blood supply from the periosteum above. So there is a benefit from the holes, but not large to make the fibroblast to go and invade it. Got it? So there is getting the advantages of both, win-win situations. Pores, small ones for better nutrition, but not large enough to make the fibroblast go and invade it. And this is the result. As I told you, there are two errors about it, and that's what we have discussed. Let's see if I can share with you. Yes, this is the software. It's a Blender. Before the software, the Blender, I have used the slicer. Slicer, the issue here is about the segmentation. You know what's the meaning of segmentation? If you are familiar with guide module, you are going to be familiar with segmentation. Segmentation, it is converting the DICOM file to 3D object, and you import by the link between the slicer and the Blender, you link between the two softwares, and you could import the STL of the bone to the Blender. And with some sort of steps or maneuvers, you can reduce the size of the DICOM file, and you can use the STL in a straightforward way. Let's see it here. Remove the light. Okay, let's hide this, and hide this, and hide this. This is the mesh I have got from the slicer. There are some open space inside it, and I use the edit mode to close it and make it filled. There is no holes, okay? So the second one will be this, and I have cut it, cut the surface to the preferred area, or just the desired area I'm working on. Okay, Let's hide this. And I have used the pluck out module to pluck out this model. It will not be okay for you to have an undercut, and the pre-step or planning or preparation for this is to pluck out the undercuts, like what I have done here. This is the offset, yeah, and let's see the target model. Yeah, this is the target model. Let's hide this, hide this. This is the target model. As you see here, it has blocked all undercuts. I have made some sort of sculpt mode here and add on brush and add a volume over the implants. Where is the implants? Let's see them. Not them, the abutment. Let's see the implants. This, yeah, this and one. Yeah, let's see Alt B. See the cross section. This is the implant covered by the bone, and this is the first position, the yellow one. It is the actual position or the real position of bone, and the white boundaries, it is the future position of bone. Can you see the difference here? Okay. Let's hide this and get out of Alt B mode. So after this, I just go for the split module and have draw my layer. This one. It was, of course, it was solid, and then I have made some sort of holes here. It's about 0.6 diameter and 10 millimeter in length, and I have made some holes. The issue here, you don't have to make it very thick, and you don't have to make it with large holes. I hope this video makes it clear enough for you to practice it. And as I told you, it is a virtual case. So go on and find your case and try it. You have to try it. Be familiar with the software keys, be familiar with software trials. And if you have any other questions regarding this case or regarding in other cases, it will be more than welcomed that I can answer it. Thank you.